Good morning to all. I hope all of you are doing well. In the last class, we discussed the topic relations and functions. And so far we have completed 6 chapters. Chapter 1, Chapter 2, Chapter 5, Chapter 6, Chapter 10 and Chapter 12. I hope all of you are completing your work and all of you are doing all the practice of the question. I will take test in a few days. And if you are finding any doubts in a particular topic or in a particular concept, you can message me or you can ask me on call also. So I hope all of you are completing your pending work. Now, the next topic that I am going to start today is the topic which all are familiar already. The topic name is probability. So I am going to start the topic. You all know what a probability means and what are the criteria, what are the properties related to probability. But now in this class 12th, we are going to discuss some important concepts apart from the previous concepts in probability, like conditional probability, Bernoulli trials, Bayes theorem, probability distribution. So there are different topics, numerous topics related to this concept. Now I am going to start. Please see it very carefully. As per the definition of probability, probability is the branch of mathematics that deals with the numerical description. It deals with numerical value of how likely an event is to occur. What is the chance of getting an event? How likely it can occur or it cannot occur, we can say. Or how likely it is a proposition is true, means an objective is true or false. This is said to be the probability. The chances of getting an event or not getting an event is called the probability. It is a number that lies from 0 to 1, where 0 indicates impossibility, the event cannot happen. 1 indicates the surety, the event must happen. And the other between 0 to 1 is the range of the probability, which is also called 0 less than equal to probability less than equal to 1. E indicates the event. Any activity that we are performing is said to be the event. Now suppose we throw a dice. The total outcomes is 1, 2, 3, 4, 5, 6. This is called total possible outcomes or sample space. I will explain all the key points or key definitions in the later part of the video. Please see carefully. If you want to calculate the probability of odd numbers, there are 3 odd numbers here. 1, 3 and 5. So we have written 3. And then total is 6 because the formula for the probability is number of favorable outcomes that we want to calculate upon number of possible outcomes. So the probability is 1 by 2. In this way we can calculate the probability of many events, but the probability must lie from 0 to 1 only. It can be 0, it can be 1, or it can be in between 0 and 1. It can never be negative and it can never be greater than 1. In the later part of the video, in the next slide, I am going to show you some of the definitions that are related to the concept of class 12th probability. Now I am going to tell you some important key concepts related to the probability. It may include some of the previous concepts also. So I am going to start one by one. Please see it very carefully. The first one is sample space. The total possible outcomes of a random experiment. Suppose we throw a die. The total outcomes are 1, 2, 3, 4, 5, 6. If I throw a coin, the outcomes are head and tail. So the total possible outcomes of the random experiment is called the sample space. The symbol is S. Next is sample points. Elements related to sample space. That is, if I throw a die, head and tail are the elements. So that are called sample points. So sample space is the total possible outcomes and each outcome of that sample space is called sample point. Now, event, a subset of sample space. For example, if I throw a die, if I am asking probability of odd numbers. So odd numbers are the event here. They are the subset of the sample space. Subset is a part of the total, we can say here. Impossible event, the event which cannot happen, that is empty set. Number of elements 13 in a year, not possible. Number of girls in a boys school, not possible. A number greater than 7 but less than 2, it is not possible. It cannot be greater than 7 and less than 2 at a one time. So that are called impossible event, and the symbol is phi. Sure event, which is 100% sure, that is the whole sample space, or we can say tomorrow is Saturday, 100% true, that is a sure event. Then complementary event. If A is an event, then not getting A is called complementary event. For example, if the probability of A is 0.2, the probability of A complement is 0.8, because the sum of the probabilities of a random experiment should be equal to 1. So if I know that the chance of winning the game is 7 by 11, then the chance of losing it is 4 by 11. This is called complementary event. Next, event A or B. OR indicates the union of the set. So A union B. A and B, A intersection B. Event A but not B means only A. B is not there. So A minus B. And similarly, event B but not A. That is B minus A. So these are all the basics related to the concepts of probability. In the next part, I am going to tell you different properties related to probability for class 12th. Now, the two more definitions related to probabilities events are mutually exclusive events and exhaustive event. Suppose we have two events. A is the event of getting odd number and B is the event of getting even number. Now the intersection part of both the sets is phi, because there is no common number between odd and even. So if the intersection part of two sets is phi, then they are called mutually exclusive events. And if I throw a die, the sample space is 1, 2, 3, 4, 5, 6, and the two sets we have are odd number and even number. If I do the union of A and B, I get the whole sample space. So they are called the exhaustive event. If the intersecting part is phi, they are mutually exclusive, and if they are doing the union and getting the complete sample space, they are called exhaustive. So there are two events, please see carefully. If A intersection B is phi, they are disjoint sets. A is odd number, B is even number. They are called mutually exclusive event because there is no common point in between, common number in between. And if even union E2 such that up to n is equal to S, that is the union of all the events give us the total sample space, they are called exhaustive event. Suppose S is 1, 2, 3, 4, 5, 6, a die is thrown. A is the event of odd number, B is the event of even number. Now union of A and B gives us S. So A and B are called exhaustive event. So if the intersection part is phi, they are mutually exclusive, and if the union is equal to S sample space, they are exhaustive. Now in the next part, I am going to tell you about the main first topic of probability related to class 12, which is conditional probability. We'll see in the later part of the video. Now the topic is conditional probability. As the name conditional states that the probability should be calculated within a condition. Suppose we have two events, E and F. We have to calculate the probability of E if F had already occurred, or the probability of F given that E had already occurred. So we are calculating the probability of a particular event implies that other had already occurred. So in that case, it is called conditional probability because one probability is dependent on the other. So the representation is like this: probability of E conditional F is equal to probability of intersecting part of both upon that already occurred, that is F. So as simple as that, probability of A conditional B is probability of both intersection A intersection B upon the already occurred, which is B. Here also F conditional E. So it can be written as E and F intersection upon E. The event that already occurred should lie down. in the denominator, and the intersecting part of both should be in the numerator. So numerator part is the favorable, and the total possible outcomes here is the event already occurred, because the one event is directly depending on the event that has occurred. So the event that has occurred is the total possible outcomes, and the intersecting part of both is the favorable outcomes. The important condition here is the denominator part probability should not be equal to 0. So this is called the conditional probability concept. If we have two events and one had already occurred, in order to calculate the other event probability, if in condition to the second one, probability of E conditional F is called the intersecting part probability divided by the event already occurred, which is F. I will explain you this with help of some questions. Now we'll see some of the properties related to conditional probability. The first one is probability of S, the sample space conditional F, is equal to probability of F conditional F. Both must be equal to 1. We can prove this also. This can be written as probability of S intersection F, as the conditional means intersecting part upon the event already occurred upon F. The intersecting part of the sample space and the event F should be F only. So the both are divided, and after calculating we get 1. Similarly here also, the intersecting part of F and F gives us F only. Upon F both cancel out and the answer will be 1. So the probability of sample space conditional F or F conditional F or E conditional E should be equal to 1 only. Next, the probability of A union B conditional F means, we all know the formula of probability of A union B, probability of A plus probability of B minus the intersecting part A intersection B. The only thing we need to add here is the conditional F. Probability A conditional F, B conditional F, A intersection B conditional F. And the third one is probability of E complement conditional F, means E should not be calculated, that is 1 minus, as the random experiment sum of the probability is 1 minus the probability of E conditional F will give us the probability of E not conditional F. See one example. Probability of A is 7 by 13, B is 9 by 13, intersection is 4 by 13. We have to calculate probability of A conditional B, which is equal to intersection part upon probability of B, because B had already occurred. So this is 4 by 13 and this is 9 by 13. Calculating, we get answer 4 upon 9. So in this way, the conditional means that intersecting part should come in the numerator and the event that had already occurred should be in the denominator in the place of total possible outcomes. I will explain you some more examples. See one more example related to conditional probability. The question is, evaluate P A union B if 2 times of P of A, probability of A, is equal to probability of B is equal to 5 by 13. So from this, probability of B is 5 by 13 and probability of A is 2 goes to the denominator 5 by 26 by evaluating, by equating it. And the probability of A conditional B is 2 by 5. So we need to calculate A union B. For that we need the intersection part also. So the conditional word means the intersection part upon the event already occurred, which is B is equal to 2 by 5. Now to calculate this, putting the value of probability of B, which is 5 by 13, and taking it to the right side and then simplifying, 5 and 5 will cancel. The probability of A intersection B is 2 by 13. Now as we know, probability of A union B is probability of A, probability of B minus probability of A intersection B. The summation of both events probability minus the intersection part, that is 5 by 26, 5 by 13 minus 2 by 13. Simplifying and solving, we get the answer 11 by 26. So to understand the conditional probability, we should understand this concept first, that the probability of A conditional B means the event B had already occurred, so it will come in the denominator, and the intersection part of A and B should come in the numerator. I will explain some more questions to you. Now we'll see very interesting question related to conditional probability. The question is, mother, father and son line up for a family picture, line up randomly for a family picture. E is the event saying that son will be on one end, F father in the middle, and we have to calculate E conditional F. This is the question from your NCERT book. Please see very carefully. Now sample space for a family picture we get, suppose we have three numbers 1, 2, 3. How many numbers we can make it from them? 6, 123, 231 and so on. In this way you can make. Here we have, out of the three people we can arrange them like this: son, mother, father, son, father, mother, mother, father, son. For a family picture, mother, son, father. You can arrange it yourself also. Total possible outcome will be 6 only. Try arranging it. If you find any doubts, you can ask me. You can message me regarding this. But it is very easy. Suppose you have any 3 numbers. How many numbers can you make? It is 3 factorial, which you already studied in class 11. That is 6. So the total possible outcomes is 6. Now the event E states that son will be on one end. So I have written son, mother, father. Son will be on the left portion. Son, father, mother. Mother, father, son. Father, mother, son. In all 4 cases, son will be at the end or at the beginning, means on one end. So the outcomes are 4 and father in the middle, F, S, F, M, M, F, S. So there are 2 outcomes for the father in the middle. Now the intersection part of E and F will be only 2, these 2 values. So the conditional E and F, E conditional F is E intersection F upon F. That is, E intersection F is 2, the total is 6, 2 by 6. F is 2, total is 6, 2 by 6, cancel out, the probability is 1. In this way, using the concept of this conditional probability, you can solve many questions. Try solving it and try to complete this exercise. Thank you.